Hello. Hello and welcome to the first of what will hopefully be many live sessions from examriz.com and me, Chris, aka the fucking maths tutor. So we're going to be dealing with quite a hefty chunk of the GCSE syllabus today in our hour and a half session. We're going to start off with some triangles, non-right angle triangles. Obviously, we know when it comes to right angle triangles, we got Pythagoras, we got SOHCAHTOA, classic trigonometry. But we're going to be dealing with the more complex side of things, the non-right angle trigonometry, sine and cosine rule, area of a triangle, and some of the more advanced exam questions you might get within those topics. So we'll kick it off straight away. Please bear with us in case there's any technical difficulties. Like I said, this is our first of what will hopefully be many of these sessions. Look at that beautiful transition. Okay, so we're going to start with area of any triangle, as we've said on here. So first of all, the formula. Now we know that when it comes to a right angle triangle, we got half base times height. We learned that in year 4 or 5 or something, and we forget it pretty soon after. But the one we need to deal with today is half AB sine C. So I'm going to write that on the page here. I'm going to get a pen. Okay. There we go. Half AB sine C. Now, when we're labeling a triangle, we label the sides A, B, and C and their corresponding angles capital A, B, and C. So the purposes of this question, this should actually be a capital C here. I didn't write it as a capital C, but I'm telling you now so you know. Because that is the sine C, sine obviously of an angle, that means this angle must be angle C, therefore making the opposite length C. Now we ain't going to use length C because that's not in the formula, but that tells us that these two lengths here are A and B. Now identifying that, we can now have enough information to plug it into this formula. So half AB sine C in this occasion is going to be half times 13 times 12 times sine 120. That is a sine, that is a 120 on the end there. I know it's slightly cut off on the screen, but I promise you, it's 120. I'm going to get my trusty calculator here. Hopefully you've got your calculators as well. And we make sure we're in degrees. Radians mode, I think that's for A level. So when you're dealing with GCSE, make sure there's a D that's highlighted at the top of your calculator. That means you're in degrees. If it says R, you're fucked. So 0.5 times 13 times 12 times sine 120 equals, and in this case we get 39 root 3. 39 root 3 is the exact answer. The question is actually asking to one decimal place, so we read the question fully because we'd fuck up otherwise, and it's going to be 67.5. So that's an added there actually. Make sure you always read the question properly so it tells you how to format the answer. My calculator was kind enough to put it in exact form there with 39 root 3, but like I said, we're going to drop some marks on that. So that's the first question we're dealing with. Let's see if we can move on to the second one. So here again, we've got the area of a triangle. That's what it's asking for. Now, this half AB sine C formula, it works when we have this kind of shape going on. Side, angle, side. When the angle is enclosed by two lengths that we know. If we don't know the length either side of that angle, then we need to do a little bit of work in order to get that. But thankfully in this question, they give it to us nice and we don't have to worry about that. We'll get to it later on how you find any unknown lengths if you need it. So once again, it is just a case of half times A, which in this case, and it doesn't matter whether A or B is 5 or 8, as long as they're either side of the angle, it doesn't matter. So a half times 5 times 8, that's an 8, times sine 41. We plug this into our calculator. Half times 5 times 8 times sine 41. And this is 3 significant figures, so we always make sure of that. And the answer is 13.1. Nice and easy. Okay, let's move on to the next question now, where it changes up a little bit. Now, we're still using the same formula, and this is really, really important. Whenever you're dealing with any question on the GCSE syllabus, if you know that there is a formula related to the question, just write down the formula straight away. So because this question has mentioned the area of a triangle, the question has mentioned it. We're not trying to fucking think of some random thing, pull it from space. They are telling us the area of the triangle. So you write down the formula for the area of a triangle. Half times A times B times sine C. I don't know why I wrote the multiplication symbols in there, I just did. But we write that down straight away. Once we have the formula written down, we can then plug in what we know. Now in this particular case, what do we know? So we know half is just a half, obviously. A and B, that's 11 and 16, times 11 times 16, times sine. Now we don't know the angle in this occasion. Don't let what you don't know stop you from doing what you do know. Just because you don't know the x doesn't stop us from just using the formula. So sine x we put, because that's, as far as we're concerned, the angle is x. But what we do know is that it's equal to 70. So now it's just an algebraic rearrangement, right? So what I would do, before I start moving stuff from one side to the other, I try and simplify one side first. So because we have this half times 11 times 16, let's just type that into our calculator. We get 88. So we know this currently is 88 times sine x equals 70. And because we're trying to find sine x, because we're trying to find x rather, we want to make x a subject, so we move the 88 through division, we get sine x equals 70 over 88. And then obviously to find x, we do inverse sine, so that's sine to the minus 1 of 70 over 88. And then we just type that shit into our calculator, inverse sine 70 over 88. And what do we get? 52.6982091, one decimal place. So that is off screen apparently, here we go. And that is 52.7 is the answer. Okay, beautiful, well done everyone. Sine rule, moving on to a new topic now, really, really exciting times for us. So the sine rule, apparently my screen is frozen. There we go, we got it back. So, sine and cosine rule. Probably the most difficult thing about the sine and cosine rule is identifying which one we have to use. So, we have formulas for them. The formulas are relatively straightforward. You actually get given the one version of the formula in the exam book, so you don't have to memorize it completely. But I'm going to show you some techniques on how to figure out which one to use, sine rule or cosine rule. So, first thing to be said is the sine rule is easier. We like the sine rule. The sine rule is the one we want to use. So we try and find out if it's the sine rule. That's our first thing. Is it the sine rule? Fingers crossed. This one is, as we know, because it says sine rule at the top, so that's a bit of a giveaway. But let's pretend we didn't see that. The sine rule formula is A over sine A equals B over sine B equals C over sine C. Now we never actually use all three fractions. It's just there to show us that any fraction can be equal to any other fraction. And when we're saying this, so A, B and C are the lowercase letters for representing the lengths, and the angles are the uppercase letters opposite those lengths. So because those are opposite, that's C. This will be A because it's opposite to that, and this one here will be B because it's opposite to that. Right now, they don't tell us, they haven't labeled the sides, which is good. If they do label the sides in the question, ignore it. They're just trying to catch you out. They're trying to say like this one is an A, but actually you need to treat it like a B. So just ignore whatever they put. They're trying to confuse you. So what do we have here? Let's start labeling some sides. So we know, so we'll call that A. Will we? Yes, we will. We'll call this lowercase a, we'll call this b, and we'll call this lowercase b. The way we identify a sine rule is we ask ourselves, do we have a pair of opposites? And when I say opposites, I mean a length and an angle. Do we have a pair of opposites that we know? Now, because here we have this pair of opposites, and we know both of them, that's the clincher. We can use sine rule. So we're really happy because sine rule is the easy one. Now, I'm just going to clear the page so we can get to work on this from scratch. So now we know we can use sine rule. we can plug into the fractions, the idea being whatever we're looking for goes on top. So because here we're looking for a length, we're going to put the lengths on top. So it's going to be 13 over sine 100 equals x over sine 38. So that is the formula you get given. And just remember how to use it. So first of all, identifying the sine rule. Do you have a pair of opposites that you know? If the answer is yes, we can use sine rule. Then what are we looking for? That goes on top. If we were looking for an angle here, and we will do later on, we'll flip this fraction upside down. Don't worry about that right now. We'll get to it later. But because we're looking for length, the length here, we can put the lengths on top of the fraction. So now it's just some very, very simple algebraic rearrangement. We want to make x the subject because that's what we're looking for. So we want to move this sine 38 and we want to move it to the other side using multiplication. So then we rearrange this to create x equals 13 over sine 100 multiplied by sine 38. And then we can just type that shit into our calculator. So 13 over sine 100 multiplied by sine 38. 8 point, how many? One decimal place. Always check how many decimal places. 8.1. And then we look at the question. Yeah, that could be 8.1. It's definitely smaller than this one. But remember, these diagrams aren't always drawn accurately. So if it ends up not looking quite right, double check it, but it doesn't mean it's wrong. Sometimes they are super shit at drawing these diagrams and their lengths don't look right when in fact you've done everything correctly. Let's try another. Work out the length of BC. So what's really important in GCSE maths is being able to identify lengths and angles that they refer to as letters. Now length is relatively easy. Length BC quite literally means the line going from point B to point C. So this is the length we're looking for. Because that's the length we're looking for, just as a standard rule, whenever we don't know the value of something, we call it x. That's just a standard thing we do. We love the letter X in maths, I don't know why, but it's helpful to us. So again, is this the sine rule? How do we know? How do we know if it's a sine rule? Is there a pair of opposites? Is there a length and an angle opposite each other that we know? Fucking yes, get in. So this 5 and 53, they're opposite each other. We know both of them. We can use a sine rule. Are we looking for a length or an angle? We're looking for a length. We know this. So we put the lengths on top. X over sine 42. Keep pressing the eraser button on this pen. It's newfangled technology for me. Still getting used to it, so I do apologize. Sine 42 equals 5 over sine 53. And very simply, we're going to multiply the sine 42 over to the other side to give us x equals 5 over sine 53 times sine 42. Type into the old calculator. 5 over sine 53 multiplied by sine 42. Three significant figures we should know how to round, right? If you don't know how to round, check out my videos on TikTok actually, if I can do that, because the videos on rounding. The answer is going to be 4.19 to 3 sig figs. Okay, what do we got here? It's another non-right angle triangle. So again, these are the trigger points we have in maths, in different questions. We see something, we're going to ask ourselves, what does that mean? This is a non-right angle triangle. We love triangles in maths, by the way. Triangles and rectangles are our two favorite shapes because we know so much about them. We should know so much about them. Non-right angle triangle, sine and cosine rule, straight, bang to the brain. Sine or cosine rule is the next question. Do we have a pair of opposites? Yes, we do. We've got the 95 and the 6.7. We love that shit. But this time we're looking for an angle. Nothing really changes here except the fraction flipped. We're looking for an angle, so we put the angles on top. So we're going to say sine x. Now remember, the sine, cos, tan, whatever it may be, affects angles only. So it's always sine angle, cos angle. Sine x over 5.4 equals sine 95 over 6.7. Shove that 5.4 over to the other side. We're going to have sine x equals sine 95 over 6.7 times 5.4. Get our calculator. Again, make sure we're in degrees. So important. The amount of marks that have been dropped due to being in radians it's horrifying. Times 5.4, and we get that sine x, can I move up here, sine x equals 0.8029, and you're looking at that and you're thinking, what the fuck, how can this angle be 0.8 when the other angle is like 95? Well, it's because we haven't found x yet. We found sine x, right? So how do we find x? We want to move sine to the other side because we want to get x by itself. Sine is not a number, so you cannot divide by sine. Sine is a function, so you have to do the inverse of the function, which is inverse sine, shift sine. So x is sine to the minus 1 of 0.8029 ... And we just use inverse sine answer. If you have a calculator that can do that, which you should, you just do shift sine answer equals, and then we get 53.4 to three significant figures. And that is a much more palatable answer. We can definitely take that. We like that a lot. Degrees as well. I like to put a little degree symbol there because it's quite fun to do a little symbol like that. I enjoy it. What we got next? So I'm going to kill you with repetition here. I know it's the same shit over and over again, but this is how we learn, right? So this one we'll go through really quick, identifying all the key topics. Non-right angle triangle, sine and cosine rule. Pair of opposites that we know, sine rule. So we write out the sine rule. We're looking for an angle, so we put angles on top. Sine x over 10, because they're opposites. That's why we put opposites over opposites. Sine x over 10 equals sine 60 over 15 times by 10. So sine x equals sine 60 over 15 times 10. Sine 60 over 15. Fuck! I did it wrong there, don't worry, I saved the day. Times 10 equals root 3 over 3, that's quite nice. So sine x equals root 3 over 3. So then inverse sine, so x will equal sine to the minus 1 of root 3 over 3. Inverse sine answer gives us 3 significant figures, 35.3, because it's 2, 6. 6 shoves that 2 up to a 3. Excellent. Okay. Now, we've got a question in context a little bit here. So, here we've got a right angle triangle next to a non-right angle triangle. So we should sense there's going to be some overlap of rules here. Because when we see a right angle triangle, we need to be thinking Pythagoras, trigonometry, SOHCAHTOA. And when we see non-right angle triangles, we're thinking sine and cosine rule. Now, the thing that's important here, the line that's joining these two triangles, this line right here, that is the most important line in the question. This line is so essential to us. If we can find it, because it combines both of these triangles, if we can find it, then we have more information for both of them. So really important. So our aim, not our sole aim, but definitely our initial aim is to try and find that length. So the way we do this is whenever you are faced with a question that's sort of 4 marks or above, do not try and find the answer. That's really important. 4 marks or above, don't try and find the answer. Just find the first mark. Just try and get 1 mark on that question, and that 1 mark will then lead to the second mark, which will lead to the third mark. So we look at it. What do we know? It's not a right angle triangle. Do we have a pair of opposites that we know? No, we don't. So we can't use sine rule. We haven't got to the cosine rule yet, so it ain't going to be that. This triangle on the right angle triangle, well, hold on. It's a right angle triangle, we know 2 lengths, Pythagoras. Mate, it's going to be Pythagoras. So just remember, when we know the longest side, we're going to do subtraction because we're looking for a smaller side. So we're going to use Pythagoras on this. 13 squared minus 5 squared, square rooted is 12. So we now know this length is 12. And hold on a second. We know that's 12. That means we have a pair of opposites that we know in this non-right angle triangle. We are in business, people. So let's get our sine rule sorted. This is another interesting one. We got 12. We're looking for a length, right? This is where it's going to get interesting. I can't wait for this. So we're looking for a length ultimately. So our instinct is we put lengths on top. So we go 12 over sine 40 equals x over. Hold on a sec. We don't know what this length opposite. We don't know what the angle opposite x is. We're fucked. It's game over. We're fucked. Unless we remember that angles in a triangle add up to 180, and we know two of the angles in the triangle. So we can easily work out the third angle, right? So 180, take away 40, take away 65 equals 75. So we know this is 75. Got a nice comment there from Claire saying this is great. Thank you, Claire. I'm glad you're enjoying it. This is great. I do agree. So now we know that angle 75, sine 75. If anybody wants to leave any comments, any nice comments, complimenting me on my math skills, I'd really appreciate that. Or if you want to ask any questions about what's going on, you can ask. I don't know if I'll answer because I'm pretty zoned in right now, but try it and we'll see what happens. Like I said, this is the first one we're doing, so there's going to be some technical hitches going on, but yeah, we'll roll with it. Yeah, there's 180 degrees in a triangle. That is correct. So let's get to work to finishing this one. So we times the sine 75 over 12 over sine 40 times sine 75 equals x. Type that shit into our calculator. We got 12 over sine 40 times sine 75. And x, at the end of the day, is 18.0. Now, on the calculator, it's 18.0325, blah, blah, blah. Now, the question says one decimal place. It's 18.0 to one decimal place, but you have to put the 0. You have to write the 0, even though 0 means nothing, because by putting the 0, you're showing the examiner, I know that the one decimal place number afterwards is a 0. So although the answer is also equivalent to 18, you have to put the 18.0 so you can say, like, look, mate, I know what's happening. I know I've rounded it correctly. There is a 0. I'm going to show you. You have to do that. Right. Here we go. Now we're combining things. This is where I love maths. This is where all the stuff comes together. We're going to combine the two things we've done to do this question, I think. Work out the area of a triangle. Okay, again, they have said the words area of a triangle, so we are straight away going to write down the formula area of a triangle. Half AB sine C. So what do you need to know? Remember, the whole idea of doing the area of a triangle is we need to have the side angle side component. So whether it be side angle side, we need to know all three of those things. We don't. So then we do, could it be this side angle side? Well, we know this side, we know this angle, but we don't know this side. If we did know that side though, we could do half AB sine C. So now our attention goes to finding that side. So that's what we want to do. Actually, I keep accidentally pressing the eraser thing. Let me see if I can deliberately press it and actually use it. No, it didn't work. Hold on. Is it working? Yeah, there we go. Okay, cool. I like that. So our attention is now going to go to finding this value. This is our aim, finding this x, we'll call it there. Remember, we don't know the value of something, we call it x. Now remember, we know these two angles in a triangle, so if you know two angles in a triangle, you can work out the third. So let's find this angle here. So we're going to do 180 minus 82 minus 40. It's 58. And now we can do sine rule because we have a pair of opposites. Wonderful. I love it when a plan comes together. So we're going to stick our unknowns on top. X over sine 58 equals 12 over sine 40 times the sine 58 over to that side. We've got x equals 12 over sine 40 times sine 58. I'm going to scroll down so you can see that. Very nice. And we're going to type into our calculator. 12 over sine 40 times sine 58. And apparently x equals 15.8319. Why did I put so many decimal places, you ask? The question says give your answer to one decimal place. Just because it's not finished yet. We're not finished. Alright? This is what so many people drop marks on. They do an equation, they plug numbers in, they get a value, and they think, I'm done. Always go back to the question, especially when it's more than 3 marks, and ask yourself, what is the question actually asking for? It's asking for the area of a triangle. Have you found it? No. You found the length. Keep working. Not slacking here. We're not done yet. Let me see if I can erase this line using that fucking... Yeah. Oh no, that just didn't work. Hold on. Yes, nice. Right, so now we know that this length is 15.8319. Still, with the idea why I did so many decimal places there is because when you're midway through a question, if you round too early, you're going to end up with a rounding error at the end. So we like to leave lots of decimal places while we're doing the working, and then only at the very end, the final answer is when we actually round to whatever value they talk about. So always leave at least 2 more decimal places than they require. So now we can do the half AB sine C. So we'll go back up to here. Half times 12 times, and it is 15.8319. But if you still have that value in your answer, you just press the answer button on your calculator. So I will type in half times 12 times answer times what will be sine 82. Because remember, it's got to be this side angle side thing for us to do the AB sine C. And then it's just plugging that shit into our calculator. 0.5 times 12 times answer times sine 82. And we get a beautiful value of 94.1 to one decimal place. Love it. Don't you just love it? Okay, how long have we got? 27 minutes. That's pretty good. 27 minutes and we've nailed 2 topics. You're welcome. Cosine rule now. Okay, so cosine rule occurs really if we can't use the sine rule. That's probably the best way I can express that. Always look for the sine rule, and if it can't be the sine rule, it's going to have to be the cosine rule. Now, this one has a slightly more complex formula. Good news is you get given a version of it in your formula booklet. I'm going to write out the version you get given, and actually let's do a little bit of work on how you can rearrange it to get the version that you don't get given. So, a squared equals b squared plus c squared minus 2bc cos a. This is what you get given in the formula booklet, and this is for when you're looking for a length. When you're looking for length a, that's this one here, you have to use angle A. So it has to be the angle opposite the one you're looking for. So you have to know the angle opposite the length you're looking for, because otherwise the formula won't work. If you're looking for A, you have to use angle A. And then in regards to B and C, it doesn't matter which other lengths of B and C, as long as they're the other ones, that's all that matters. Actually, I'll tell you what, because we're looking for a length in this one, let's just go ahead and do this question. And then when we start to have to look for an angle, I'll show you the alternate version. So once you've identified it's the cosine rule, the hard work is done, in all honesty. We just need to plug the correct numbers into the correct places. So because we're looking for x here, this is going to be our A value, which means this will be B and C. Like I said, it doesn't matter which one's which, as long as that is angle A and B and C are those two. So we're going to have x squared, because x is A. X squared equals 10 squared plus 13 squared minus 2 times, and I'd probably put this in brackets. Your calculator is clever enough to do big maths, do the multiplication before the addition and subtraction, but I'd still put it in brackets anyway, just to be super safe. 2 times 10 times 13 times cos 100. And then, to be fair, we just chuck into our calculator just like that. A lot of teachers say, oh, do every bit individually and get your 10 squared, get your 13 squared, and get your... But fuck that. Shove it into your calculator. You have a calculator for a reason. It's clever. It's cleverer than all of us put together, pretty much. So just fucking do it. 10 squared plus 13 squared minus brackets 2 times 10 times 13 times cos 100. And we get x squared equals 314.148 dot dot dot. And you look at it and say, how can that length be 314 point something? The other ones are 10 and 13, it can't be. Well, it's because you haven't square rooted it. This is x squared, all right? X squared, so we need to now find x simply by square rooting it. So x is going to be the square root of that, so you go square root answer equals, and it is 17.7 to 1 decimal place, which looks like it's right. Okay, got a nice question from Ben here. What if the question asked me to find the obtuse angle in a triangle? So that will be on a sine rule question is the only issue. Cosine rule, it will be fine, and we will get to that. But yeah, cosine rule will work, I imagine. But when it's a sine rule and it's asking for the obtuse, do it as normal. Your calculator will give you the acute angle, then you just minus it from 180. Because the whole idea of it, and I'll do really, really quickly here, a sine curve looks like this. So this is 90 degrees here. So these are all acute angles from there to there, and these are all obtuse angles from there to there, because this is 180. So this is between 90 and 180. And so for any one particular value, you can have an acute and an obtuse. So the calculator will always give you the one closer to 0. So then just do 180 minus that angle, and you end up with the obtuse. If we can find a question where I can actually show that, I certainly will do. But for the time being, you'll have to take my word for it on that one. But we will do our best to give you an example to finish that one off. Okay, let's move on to this next one. Work out the length of BC, give your answer to be significant figures. Okay, so we've got a non-right angle triangle. Remember, this process of deciphering whether it's the sine or the cosine rule is really, really important. So we've identified it's a non-right angle triangle, sine and cosine rule. Do we have a pair of opposites for the sine rule? No, we fucking don't, unfortunately. So it's going to be the cosine rule. We are looking for a length, so we can use the formula that is given to us in the formula booklet. A squared equals b squared plus c squared minus 2bc cos A. And again, knowing that that is going to be length A because this is angle A. So A squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cos 42. Stick some brackets around there just for fun, just to be on the safe side. And we do 5 squared plus 7 squared minus 2 times 5 times 7 times cos 42, bracket, bracket. A squared equals 27.97986. A, however, we always remember we've got to square root it. Square root answer. And how many decimals? 3 significant figures, 4.69. Remember, 3 significant figures means there's just going to be 3 numbers, non-zero numbers. Significant figures start from the first non-zero. Okay. Non-right angle triangle. Do we have a pair of opposites that we know? No, we have this pair of opposites, but we don't know both of them, so we can't use the sine rule. It's going to be cosine rule, and it's going to be an angle. Oh shit, here we go. Okay, you don't get given this formula. All right, you don't get given this formula for in the formula booklet, so we're going to need to rearrange our formula. Now you got 2 options. Let me give you the one that's in the formula booklet. A squared equals b squared plus c squared minus 2bc cos A. You can either rearrange this formula to make cos A the subject, or you can memorize the formula. Now, if I were you, I'd learn to rearrange it. The less you have to memorize, the less you're relying on your memory, the safer you will be. Imagine going into your exam and you've memorized so much stuff. If you forget something, you're fucked. But if you know how to rearrange something you're given to get that, you just know the process, then you don't need to memorize it, you can always work it out. So the way we do this is we want to make cos A the subject. So we're going to add 2bc cos A to the other side, and we're going to minus the a squared to this side, which will give us 2bc cos A equals b squared plus c squared minus a squared. And then we're going to divide by the 2bc. So we're going to be left with cos A equals b squared plus c squared minus a squared over 2bc. So that's the formula we're going to be using for this particular question. And I'm going to try and delete this. Am I going to succeed? This is pretty good. Nice and smooth. Excellent. So we're looking for angle A. So this has to be angle A because that's what we're looking for, which means this has to be length A. Really, really important that the A's are opposite each other. Then once again, it doesn't matter which one of these is B or C. We'll just do it that way around. So cos X in our case here, 15 squared plus 16 squared minus 20 squared over 2 times 15 times 16. And this once again is just plugging shit into your calculator. So fraction 15 squared plus 16 squared minus 20 squared over 2 times 15 times 16 equals 27 over 160, aka, so cos A equals 0.16875. And remember, that is not the answer, that is cos A, we're looking for A. So A equals inverse cos, shift cos, cos to the minus 1, whatever you want to call it. So shift cos answer equals 80 point, three significant figures, 3. This is 80.28. The 8 shoves the 2 up to a 3, and we're all good. That's how we do that one. I'll tell you what, we'll skip question 6 because we're coming along. Wow, we are racing through these, racing through time actually. So let's just jump to this next one. So once again, we've got conjoined triangles here. We want to, our aim is to definitely find this length because that's the one that combines the two triangles. So if we know that, we know so much more information. So we look at what we can find. Look what we have. We have a non-right angled triangle, and actually we've got a side angle side. Side angle side is one of the trigger things for either area of a triangle or cosine law. So the fact we have that means we can use that to work out this middle length. Ideal. So we're going to do a squared equals 13 squared plus 10 squared. A squared equals b squared plus c squared minus 2, 10, 13 cos 40. And we just type in the shit into our calculator. A squared equals 13 squared plus 10 squared minus 2 times 10 times 13 times cos 40. 69.828. Square root that to get A equals 8.3563. And remember, we're not finished. We found A. That don't mean shit until we find X. So this is 8.3563 dot dot dot. And then now, because we're in a right angle triangle, we're just going to use regular trigonometry. SOHCAHTOA, classic. So because it's the, according to this angle, it's the opposite and the adjacent. So we're going to use TOA. So we write out our SOHCAHTOA triangle. Do it absolutely mini here because, well, and I've accidentally deleted it because of this button on the pen. But it's probably for the best because I drew it far too small. So it's funny how things work out. TOA. Cover up what you're looking for. You're looking for the angle. So we cover up that and we're left with opposite over adjacent. So it's going to be tan to the minus 1, 8.3563. Opposite over adjacent is 5. Inverse tan. It's the first time we've used tan today. Feels nice. Feels like we're on a holiday getting a tan. Brilliant. 8.3563 over 5. And that is 59.1 is the answer. Boom! Love that shit. Okay. I think we'll put a pin in that for this topic. We've done a lot of triangle work today. What time are we on? That's been 40 minutes. We've got a couple more topics to get into. So I'll tell you what, we'll skip that. Let's move on to sequences. We love a bit of sequences. If we do have time at the end, we can come back and finish off that question, like a little recap. at the end. So let's do some sequences here. We're going to start off relatively basic. I'm going to go through these ones quite quickly, just to get us up to speed. So nth term of a sequence is 4n plus 3. Find the first two terms of this sequence. So n literally means the number of the term. Which term? The first term, second term, third term, the nth term. So if we're looking for the first term, that's when n equals 1. So you quite simply sub n equals 1 into the equation. So in this case, that's going to be 4 times 1 plus 3, which is 7. And then to find the second term, you just sub 2 into the equation. So 4 times 2 plus 3. So it's going to be 8 plus 3 is 11. Simple as that. Is 35 a term in the sequence? That's the next question to ask. Well, if 35 was a term in the sequence, then there would be a number you could plug in to 4n plus 3 to equal 35. So you could use trial and error. You could use plug in some values. You could say n is 10, and then you got 40 plus 3, 43. And you think, okay, maybe I'll go a little bit lower. I'll try 5. 4 times 5 is 20 plus 3 is 23. And so you set somewhere in between there. That works all well and good until you get some really large numbers. So what I'm going to do is I'm going to show you a method that works all the time, on every occasion. And that is to equate the equation with the value you're trying to find whether it's in it, which is what I've done here. 4n plus 3 equals 35. So what we're going to do is try and find n. So we minus 3 from both sides. We get 4n equals 32. And then divide by 4, n equals 8. Now because n equals 8, that means the 8th term is 35. So we're all good. It is in the sequence. If we didn't get an integer value, if we got like 8.5 or 7.9 or something like that, or just a horrible fraction, that means it's not in the sequence. If we get an integer value, by integer I mean whole number, not a decimal. If we get an integer value, that means it is in the sequence. So we're all good. Here are the first 5 terms of a sequence. Find the next term of the sequence. Well, one of the standard things we do in sequences, regardless of what type of sequence is try and find the difference between the terms. So 17, 14, 11. So it's going down by 3, minus 3. This one is also going down by minus 3. Well, it's going down by 3. It's not going down by minus 3, it'll be going up. But it's going down by 3, meaning obviously the next term is also going to go down by 3, so it's going to be 2. So the answer is indeed 2. Nth term of a different series is 10n squared plus 5. Work out the 5th term of this sequence. So once again, n represents the particular value of the term that we're looking for. If we're looking for the 5th term of the sequence, n equals 5. If we're looking for the 10th term of the sequence, n equals 10. But we're looking for the 5th term. So 10 brackets 5 squared plus 5. Remember bib maths here, and always use brackets when you're subbing something in. So 5 squared is 25, 10 times 25 is 250, plus the 5 is 255 is the answer, is the 5th term of the sequence. Song Kim, please could you correct sequences? Don't you worry, we are getting there, my friend. We are going to be getting there. This is all build up for that. That's the main show in this topic. Here are the first 5 terms of Fibonacci sequence. Who knows what Fibonacci sequence is? I'm just going to give you 1 second right now. Put in the comments. If anybody knows what Fibonacci sequence is, just be like, yeah, or obviously, or like easy, or whatever, if you know what Fibonacci sequence is. If you don't worry. It's quite fun. It's this geezer called Fibonacci came up with it years ago. Like, well over a couple of years ago. And the idea of Fibonacci sequence is, nobody's commented, I'm guessing. Nobody knows what Fibonacci sequence is. Which is a shame, but you're going to know in a minute. The way you work out a Fibonacci sequence is just you add the previous 2 terms to work out the next term. So here, we've got 2 plus 2 equals 4. 2 plus 4 equals 6. 4 plus 6 equals 10. So obviously, the next term is going to be 6 plus 10 is 16. It's asking me the 8th term, so we've got to go a couple more. The next one is going to be 10 plus 16 is 26. I think that's the 7th term, so one more. So 16 plus 26 is going to be 42. 42 is the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. Yes, indeed. That's Fibonacci sequence, just adding together the previous 2 terms to work out the next one. Okay, I don't think we need to do question 10 because we've kind of covered that in the previous ones. Then we like to give us geometric problems, so visualizing some of the questions here. Pattern 1, 2, 3, and draw pattern 4. So the thing you've got to do, first of all, don't think it's too easy right now, because we can see it looks like a cross, and then the what's happened to my pen? Now we're back. It's got a cross, then it's 2 crosses, 3 crosses. If you drew like 4 crosses worth of dots, you could be forgiven for thinking that was the answer, but you'd be wrong. You'd be horrifically wrong. So here's what we do. What we do is we're going to take a break, just for 5-10 minutes, just while we get, while we have a glass of water and refresh the stream perhaps. But do join us back in about 5 to 10 minutes, and we will carry on with this. Welcome back. Sorry about those technical issues. Apparently it was lagging a little bit. Hopefully it's not. Hopefully we've fixed all those issues and you should be hearing me loud and clear. Just like this fly is. I didn't get it. It's okay. We can all live harmoniously in here. Okay, so we were dealing with some these sequences, the images of sequences that are giving us. Now sometimes these can be a little bit tricky. So what I really want you to do in these type of questions is figure out what is actually happening, what is being added or taken away or anything like that with these sequences. So what's happening is this is the original one, and the original one sort of stays in here. So what they're actually doing is they're adding 4 dots on the end. And then you'll find that in this next one, that's pattern number 2 with the 4 dots on the end. So when you're drawing pattern number 4, we're going to just do pattern number 3 in its entirety first of all. So that's dot, 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 dot with the extra 4, pattern 2, with the extra 4 is pattern 3, and then with the extra 4 is pattern number 4. So don't rush it. It is only 1 mark, so which makes you think it's quite easy, and it is easy, but don't rush it. Always just take the time to figure out what is actually happening. Then the total number of counters to make pattern number 10. Now, you could be super long and draw out all of the patterns up to pattern 10. Or you can figure out the nth term. Now, I think we're going to get to that in the next section. Yeah, literally the next question, so I may as well start doing it now. Figuring out the nth term is a really important technique, and it's so easy as well. It's one of those questions where you learn it in school, and usually your teachers take like a whole lesson to explain it. I'm going to explain it to you in less than a minute, probably less than 30 seconds, and it's the fucking easiest thing you've ever seen in your life. So here, let's first of all put these patterns into numbers. So here we've got 5 dots, this one we've got 9 dots, and this one we've got 9, 10, 11, 12, 13 dots. So what we do, the sequence currently is 5, 9, 13. Find the difference in terms, so it goes up by 4, up by 4. So that is going to be 4n. That is going to be the beginning of our answer. Because it goes up by 4, it's 4n. And then what you do is you just find the number that would be before the first one. So if there was a number that goes there, what would it be? Well, because these are going up by 4, the number before it would be 4 below, which would be a positive 1. 4n plus 1. Because the number before the first one would be a positive 1, we do plus 1, and that is it. That's the nth term. Fucking done. How easy is that? Now let me show you on another question how easy it can be. Here are the first 5 terms of a sequence. Find an expression in terms of n for the nth term of the sequence. So we count up. 5, 5, 5, 5. That means 5n. What would the number before the first one be? Well, it would be 5 below it, which is a positive 4. That's it. Unbelievable how easy this is. Now, this next one. Be careful. 3, 3, but down 3. They're going down 3 each time, which means it's a minus 3. Don't fall for that trick. They're going to try and catch you out with that one. Minus 3n. What would be the one before? It would be up 3. 3 higher. A lot of people make the mistake of and try and work out what the one down here would be. That's not the rule, okay? The rule is before the first one. So this one up here, it would be 25 plus 3, which is 28. And that's the answer. So that's basically the same for all these, so we kind of don't really need to practice all of those. Let's do this last one just because, fuck it, let's just do this one. Because it's another negative one, and I know people get caught out on these a lot. It's minus 4 in all of these. Minus 4n, and then the term up there, positive 39. Nice and easy. That is the nth term. Oh shit! Here it is. Quadratic sequences. This is the big one. This is what you've been asking for. Alright? We're going to do it. I'm just going to have a sip of coffee. That's good stuff. So, write the next 2 terms in the following quadratic sequence. So obviously they're not asking us to find the nth term of quadratic sequence yet. We're building up to it. Building the tension, the anticipation. So as always, we find out the difference between these terms. This goes up by 4, this goes up by 6, this goes up by 8. This is how we know it's not a linear sequence, because the terms are going, the differences are increasing. So this is how we can sense it's a quadratic one. So the next 2 terms, well, we follow the pattern in the differences. That means this difference is going to be 10, meaning the first one is going to be 37. And then the next difference is going to be 12, meaning the last one is 49. So relatively straightforward for those 2 marks. Just remember, when it comes to sequences, finding the difference between the terms is always the first step. If the difference is the same, it's a regular nth term, and we stick that number in front of the n, then plus or minus whatever the 0th term is, the term before the first one. And yeah, just follow that pattern. Now, much like the regular nth term, to find the 10th term, we just substitute in n equals 10. So that's what we'll do here as well. So it's going to be 2 brackets 10 squared plus 4 times 10 minus 1. So remember, bid math, we're going to do the indices first, then the multiplication. So it's going to be 10 squared is 100, so 2 times 100 is 200, plus 40 minus 1, which is going to give a grand total of 239. Here we go. Okay. Now, there's a few different methods for actually doing quadratic sequences. I'm going to show you the one that I find the easiest. Now, if you have an alternative method or have been taught a different way and you're happy with that, stick with that. I don't want to try and change something you're already okay with. But if you hate quadratic equations, quadratic simultaneous, that's another thing. We'll get to that some other day. But if you are dealing with if you don't like quadratic sequences, I think the method I'm about to teach you is probably the best way. So it takes a bit of repetition because there's a few steps to remember. So repetition is the key with remembering stuff. That repetition moves stuff from your short-term memory over to your long-term memory. So make sure you do some practice after this, but we'll go through a few now. First step, as ever, find the difference between the terms. So the difference here, 6, 8, 10, 12. Then we find a second difference. And this second difference should be the same. 2, 2, 2. That's good news. Okay. So what we do, it's a little bit confusing at first, a little bit to remember. We half the second difference. Really, really important you remember that. We're going to half this 2. And that is the number that goes in front of the n squared. So half of 2 is 1. So it can be 1n squared. And that's actually going to make up the first bit of our answer. Our answer is just going to be, it's going to start with 1n squared. We don't need to write the 1 because n squared is just 1n squared. So that's the first step. Half the second difference. So what we do at that stage is we say, okay, so right now we know it's going to be 1n squared. Let's write out the sequence for 1n squared because that's what we currently have. Now the sequence for n squared is just 1 squared, 2 squared, 3 squared, 4 squared, etc. So 1, 4, 9, 16. Goes on. Now we're going to subtract the original equation. We're going to subtract this from the original equation. So we're going to do 5 take away 1 is 4. 11 take away 4 is 7. 19 take away 9 is 10. 29 take away 16 is 13. So that's another really important step to remember. And look, this does take some memory power here. All of these steps are going to seem pretty random at this stage, but after you get the hang of it, after you get to grips with it, it will become second nature. And all of the maths involved is really straightforward. That's what's really important to remember. The maths is very simple. It's just halving, squaring, subtracting. It's just the steps is what's difficult to remember. Now we've subtracted these, what we actually have is a regular nth term sequence, the ones we've just been doing. That's why we were doing that practice earlier. So this is a regular nth term sequence, goes up in 3s, so it's going to be a 3n, and this is going to become part of our answer, plus 3n, and the 0th term, the term before, will be a positive 1. And that's the answer. So there are two very separate stages of this question. To work out the n squared, the coefficient of n squared, or the value in front of the n squared, we half the second difference of the original equation. In this case, 1n squared. Then we use that to find a new equation through subtraction of the original equation, take away what we currently have, to get a new linear nth term. Linear meaning it goes up by the same amount each time. Or arithmetic sequence, as some people refer to it. And just find the regular nth term of that. Just stick it on the end. So let's use that exact same technique for this next question. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Straight away, we're going in for finding the difference. Bang, 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 bang. Difference. 8, 12, 16, 20. And the difference of the differences is 4, 4, 4. What's the next stage? Half the second difference, and that will be the coefficient or number in front of n squared. So that means it's going to be 2n squared. So that's what we currently have. And we can actually just write that on the answer line straight away, because we know that is going to be the beginning of our answer. 2n squared. So we write out the sequence of 2n squared, basically saying this is what we currently have, because we know it's going to be 2n squared. So what is 2n squared? That is 1 squared times 2. 2 squared times 2. Again, using BIDMAS, we have to do the indice first, the squaring, then times the multiplication. So n squared, so 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. And 4 squared is 16 times 2 is 32. Remember, subtraction. And I always write it in this form because if we have the top line up there And what we've just found here, it's much easier to remember. It's that, take away that. Top, take away bottom. If you try and rewrite it, it gets a bit complicated. You have to try and remember which way round is it. So I just like to leave it in this exact form. I think just to point out, these live sessions will be re-watchable afterwards. I think you can be able to look at them again. So if this isn't making perfect sense, or if you feel like you need to go over it a couple more times, you will have the opportunity to do so. Now we're going to do subtraction. 2 take away 2 is 0. 10 take away 8 is 2. 22 take away 18 is 4. We're going to put commas between these. 38 take away 32 is 6. And we've got ourselves a beautiful, lovely little regular nth term. The difference of which goes up in 2's each time. Positive 2, so we're going to write plus 2n. And the 0th term down here was going to be a minus 2, so we minus 2 there. That is it. If you have time in an exam, what I would recommend is you actually plug in a couple of values for n to make sure you get first term. So for example, plug in n equals 1, and you're going to have 2, 1 squared plus 2 times 1 minus 2, and you should get the first term. So 1 squared is 1 times 2 is 2, plus 2 minus 2 equals 2, which is the first term. So we know that when we plug in n equals 1, we get the first term. So by all accounts, makes sense. If you want to plug in the second term as well to be super sure, go for it. Make sure you have enough time. Time management is very, very important in GCSE maths. And in life. Here are the first 5 terms. So same thing again, we're just going to race through this one again, just to drill it into your brains. Hopefully this is making sense. If anybody wants to leave any comments saying that they need a little bit more explanation or need me to slow down or something, just let me know. But otherwise, we're just going to crack on with this one. So, what's our steps? Find the difference. As ever, any sequence, always finding the difference. 4, 6, 8, 10. Double difference. 2, 2, 2. Half that shit, and that's the coefficient of n squared. I keep saying coefficient. I don't know if you, a lot of people don't know what that word means. Coefficient means number in front of. So, for example, if we had 2x, the coefficient of x is 2. If we had 3x squared, the coefficient of x squared is 3. That's what that means, just to clarify. If you want to get into A-level maths, the word coefficient is going to be very important. So you can dazzle your school teachers and all your friends by knowing what coefficient means. God knows I used to. So we're going to half that number to get 1n squared, and that's going to be value. I'm going to write that straight on the answer line because I know that's going to make up the first part of my answer. The sequence of n squared is 1, 4, 9, 16. We need to know our square numbers, guys. Hopefully you do. Then we're going to do some subtraction. 15 minus 1 is 14. 19 minus 4 is 15. 25 minus 9 is 16. This is looking like a very nice sequence. And the next one is going to be 17. So these are going up by 1, so it's going to be 1n, positive n. And then the 0th term will be, I don't know why I wrote a negative there, will be 13, positive 13 that is, plus 13. And that's how you do quadratic sequences. Hopefully that's making sense to you. That's like a level 9, grade 9 topic. So as you can see, questions are worth like 4 marks, 4 marks, and then 4 marks. So I think we can categorically say that the question is worth 4 marks, which is a nice chunk of your GCSE exam. So we will skip these ones because they're basically the same thing, and we're going to move to recurring decimals now. Recurring decimals is a really nice little topic. I actually love teaching recurring decimals. It's one of my favourite to teach. Maths is so based on structure. If you know the structure of any topic, they can't catch you out because you're just plugging different numbers into the same structure and you're going to get it right every time, in theory. But the structure around recurring decimals to fractions is so solid that, I don't know, for me it just feels like a really, really good, solid topic because if you know the structure, you will never fucking get it wrong. And I love that shit. So we're going to start with these 2-mark questions here, converting fractions to decimals. So just to clarify, you probably won't get this type of question on an IGCSE paper because as IGCSE students will know, you only do 2 exams and they're both calculator. So you can just type this shit into your calculator, it's not a problem. But regular GCSE students are probably looking at this being like, what the fuck, they get calculators for everything? Yes, they do. You have to do an extra exam, it's a non-calculator exam. I'm sorry, that's just the way it goes. They have to learn other extra topics that you don't, so swings and roundabouts. Convert 2/9 to a decimal. What people don't remember, or people don't realise, is that a fraction, quite literally, is a divide symbol. This blew my mind when I realised it. A fraction, 2/9, it just is a value over a value. It is a divide symbol. I fucking love this shit, man. This is why I love maths. A fraction is a divide symbol. That's where the division symbol came from. Maybe that's where a fraction came from. I don't know the order. I just love the fact that it happened. So fraction means divide. So for this, we just do bus stop method division. So 2 divided by 9, or 9 into 2. So 9 goes into 2 0 times, obviously, but that allows us to create a decimal point on the top and bottom where we just can put as many zeros as we want, because 2.000 is the same as 2. So it goes into 2 0 times, remainder 2. 9 goes into 20 twice, remainder 2. Goes into 20 twice, remainder 2, and I think we can see where this is going. This is just going to be 0.2 recurring. That little dot above the 2 is the recurring symbol, meaning this number is going to go on forever. 4/11. So 4 divided by 11. 11 goes into 4 0 times. So we stick a decimal point to allow us to stick a few extra zeros here. 11 goes into 40 3 times, remainder 7. Because 11 goes into 33. 3 times, you need an extra 7 to get up there. Scroll down a little bit so you can see it. 11 goes into 7 6 times, because it goes up to 66. And that's going to go as a remainder 4. And it goes in to 40 3 times. And I think we can see where this is going again. So 363636. So the answer is 0.36 recurring. And these dots are meaning it's going to be recurring between 3 and 6. 3, 6, 3, 6, 3, 6. I'm going to make a point about these recurring dots later on. We're going to get to it because there's a very, very common misconception about what these dots mean in other circumstances. But for the time being, in this one up here, it's 0.2222. In this one here, it's 0.36363636. Okay, so now we get to the actual prove algebraically that the recurring decimal 0.8 recurring can be written as 8/9. So this is the structure that I've been talking about. This is the structure I've been raving about that we love. Let me just figure myself out here. Okay. What we do is we say x equals the number they've given us. X, just leaning on my thing here, x equals 0.8. I'm going to write it as 0.8888888 because that just is what recurring means. So we're just going to write out several 8s to just help ourselves out visually. Now what we're going to do is we're going to keep multiplying both sides by 10. Just keep going until we reach a point where both numbers are exactly the same after the decimal point. So we times x by 10, we get 10x. We times 0.8 recurring by 10, we get 8.888, etc. Going on forever. We're already there. We're already at the stage where these two numbers are both exactly the same after the decimal point. They are both 0.8888. So because we've reached that stage, we can subtract these lines from each other. So we're going to do 10x, so this bottom one take away the one above it. So 10x take away x is 9x. And then 8.888 recurring, take away 0.88 recurring. This is the magic of this one. The recurring 8 just cancel out. So it's 8 take away 0, which is 8. Then to find x, which was, remember, our original value was x is 0.8 recurring. X equals 8/9 because we're just dividing the 9 to the other side. So that is how we show the 0.8 recurring can be written as 8/9. Let's try this one. Prove algebraically that the recurring decimal 0.23 can be written as 7/30. So I just want to clarify exactly what the dot above the 3 represents here. It means this number. is recurring in this situation. The dots represent the beginning and end of the recurring cycle. So if there's only one dot, there's only one number that is recurring. So we're going to say x equals 0.23333 because the dot is only above 3. So that is the beginning and end of the recurrence. And we're going to keep timesing by 10, like I said, until we get two numbers that are exactly the same after the decimal point. So we'll say 10x equals 2.333 dot dot dot. That's a dodgy 3. Now these are not the same after the decimal point. The top one is 0.2333. The second one is 0.333, not the same. So we keep timesing. So we get to 100x equals 23.333 dot dot dot. Now these are the same. This one and this one are both 0.3 recurring. So these are the ones we can subtract from each other. 100x take away 10x is 90x. 23.3 take away 2.3, both recurring. The recurrings just cancel out. That's the whole point of this. That's the genius of this. So we just end up doing 23 take away 2, which is 21. So x is going to equal 21 over 90. And that will, if we divide top and bottom by 3, equal 7 over 30. So that's how we do that one. I think we'll maybe skip question 10 because it's pretty similar to the ones we were just doing. But just to clarify, this would be... Actually, we're not going to skip question 10. I think it's really important. I chose these ones for a particular reason. We'll just go through them a little bit quicker. 0.68818181. Again, the dots show the beginning and end of the recurring cycle. So 8 and 1 means those are the ones it recurs between. So we go to 10x equals 6.8. What's happening with my pen here? Having a little bit of a lag on this pen situation. Let's try and get it back. Sorry guys, just bear with me. Whoa, the tab has crashed. This is panic stations now. I'm just going to try and reload this. So let's just take a minute to chat about recurring decimals to fractions. I think if memory serves me, the question was 0.68188181. If you times both sides by 10, you get 6.818181. So the top line is 0.681 and the second line is 0.81. They are not the same after the decimal point. So we need to continue and we times both sides by 10 again to get 100x. I think we are back up. Are we back up? Oh, look at that. So 6.818181. Like I said, they are not the same, so we need to go to the next. 100x equals 68.181818. Still not the same. We got 0.681 here. We got 0.818 and we got 0.181, which means we continue. We do another set, and we can go for as long as we need to until we get two numbers that are exactly the same after the decimal point. Sisyphus says thank you. You're very welcome, Sisyphus. 1000x equals 681.8181. And look at this, these two. These two are exactly the same after the decimal point. They are both 0.818181. So those are the ones we take. We'll just ignore this question for the time being while I'm still writing out the working here. So we're going to do 1000x take away 10x, which is going to be 990x. And then because the 0.8181s will cancel out, we're just doing 681 take away 6, which is going to be 675. Divide that shit, 675 over 990. And then to be honest with you, probably at this stage we'll just plug this shit into our calculator, or to end up with 15 over 22. Yeah, we don't need to worry too much about whether that's going to simplify. Shove it into your calculator, it will do. Okay, now we'll move on to this next question, and this is one I really wanted to focus on, because I'm just going to get rid of that so we can just focus on this one. This particular question, a lot of people make mistakes on when the dots are in this form. So remember, the dots represent the beginning and end of the recurrence cycle. They don't only represent the numbers that recur, it's the beginning and the end of the recurrence. The mistake people make is they write this as x equals 0.2162626 because the dots are above the 2 and the 6. That is wrong. What it is 0.216216, the beginning and end of the cycle. The beginning is 2 and the end is 6. Everything in between goes along with that cycle, is part of the cycle. So we're going to keep times in by 10. Now, some of you may be thinking you can spot that it recurs after every 3. So if you want to jump ahead, skip the 10 and the 100, that's fine if you know it's going to be 1,000. But in all honesty, if you're not 100% certain about that, I would do the step-by-step process. Like I said, maths is all about structure. And because we have this structure, if you stick to it, you will always get it right, as long, aside from some stupid mistakes that everyone is capable of making. So 10x equals 2.162162. 100x equals 21.62161. And 1,000x equals 216. And we've crashed again. 216 point, and we're back. 216.216216, and we have the beginning one and the last one both being 0.216. So we can use those. So 1,000x take away x is 999x. Do not make the mistake of saying 1,000x take away x is 1,000. Please don't do that. Because 1,000x take away x is take away 1x. So leaving us with 999x. And then, as we know, everything after decimal point cancels out, because that is the beauty of this topic, leaving us with just actually 216. And then x will equal 216 over 999, which I'm sure will cancel down to 8 over 37. We do have, how long have we got left on this? We've only got 5 minutes. Okay, because we've only got 5 minutes, we're just gonna round off this topic. I'm not gonna start a new topic because I think we won't have enough time to actually embed it into our brains. So let's do some really complex versions of these. Hopefully you've understood how the process works of this, how the structure works. And this is an example where they bring algebra into the equation. And I said right at the very beginning of this session, don't let what you don't know stop you from doing what you do know. We know the structure of how to do this topic. Just because they put an x in there, that should not stop us from doing the exact same structure. X is an integer such that x is between 1 and 9 inclusive. So 1 all the way up to and including 9. Prove that 0.0x recurring on the 0 and the x is x over 99. Now, this looks very different. I know it does. It looks pretty fucked up, but we're just going to do the exact same thing. Probably won't use x equals for the time being because they're using x as our number. So let's say y equals. So y equals 0.0x, 0x, 0x, XOXO, classic Gossip Girl reference. Then we're just going to keep times in by 10. The same structure until we get two numbers after decimal point that are exactly the same. 10y equals 0.xoxo. Then 100y equals x.0xox. And now these two are the same. So we're going to minus them from each other. 100y take away y is 99y, of course. And then everything after decimal point cancels out, leaving us with just x take away 0, which is x. Therefore, y, our original number, as we labeled it, is x over 99. Love this shit. This is so good. Okay. This will probably be the last question we do. Actually, let's see. If we can do it real quick, we might go back up and do something, do a recap from a previous one. But let's see. So now we got a recurring decimal multiplied by another recurring decimal. Do not try and times these decimals straight away. That's not what they want. When you see a recurring decimal, we want to turn it into a fraction. That's just how we do things. That is our motivation here, and that is our process. So let's take 0.54 straight away. X equals 0.545454. 10x equals 5.4545. 100x equals 54.5454. These two are the same. We minus them to get 99x equals 54, because all those cancel out. X equals 54 over 99. Then right next to it, let's do 0.5 recurring. So that's going to be, let's say y, because we've used x already. Y equals 0.555. 10y equals 5.555. These two are exactly the same, so we do minus them. 9y equals, those all fuck off. 5y equals 5 over 9. I know I went through that pretty quickly, but hopefully you're up to speed given the ones we've done already. Now we times the fractions. This is what we do. So it's going to be 54 over 99 times 5 over 9. Now, God knows whether this is going to be on a calculator or a non-calculator paper. I am going to use my calculator now because fucking can't be asked to do it longhand. But if this does come in a non-calculator exam, I'm afraid you are going to have to do 54 times 5 over... Actually, hold on. I've just spotted something. When we're multiplying fractions, we can help ourselves out by cross-cancelling. So this is when you have a fraction, you can cancel it down. You can simplify the fraction if there's a number that goes into both the numerator and denominator. But when we're multiplying them, we can actually cross-cancel. And because 54 and 9 are both divisible by 9, we can cross-cancel them both by 9. So divide that by 9, we get 1. Divide this by 9, we get 6. So now actually this is a much easier thing to do. 6 times 5 is 30. Over 99 times 1 is 99. And then we can actually divide both of these by 3 to get 10 over 33 as our final answer. So you probably will get this in a non-calculator exam, if I'm being honest, because you can do that sort of stuff and cross-cancel and simplify the fraction. I don't want to be the one to do 54 times 5 and 99 times 9. That's not nice. Song Kim wants one more quadratic sequence. Fuck it, let's do it. We're feeling good today. We do have one more example anyway. Show the nth term is this. So remember the structure. Find the second difference. First difference is 4, 6, 8, 10. Second difference 2, 2, 2. Half the second difference, and that is the coefficient of n squared. So in this case, it's going to be 1 n squared. So we're going to write the n squared sequence, and we'll write n squared on our imaginary number line as well. The n squared sequence is just 1 squared, 2 squared, 3 squared, etc. So 1, 4, 9, 16. Minus. Remember, we write it in this structure so that it reminds us that we do top take away bottom. 6 take away 1 is 5. 10 take away 4 is 6. 16 take away 9 is 7. 24 take away 16 is 8. And we find the regular nth term of this new sequence. So they're going up by 1 each time. So it's going to be plus 1n, or just n. And the term before that one would be a positive 4 plus 4. And that's how we get this. And just to quickly clarify on part B here, hence determine whether 136 is determine the sequence. Just like with regular nth term, we just make that value equal to the sequence with the idea that if it is in the sequence, there will be a value of n which creates 136. So we just do n squared plus n plus 4 equals 136. And then we just solve this like a quadratic. Move everything over to one side and try and factorize it. So it's going to be n squared plus n minus 132 equals 0. And we're looking for two numbers that times together to make 132 and add or subtract to make 1. And we should know, if we're hot with our times tables, that's going to be 11 times 12. And to get positive 1n, it's going to be plus 12 minus 11 equals 0. And then that means n equals positive 11, n equals negative 12. Because we cannot have a minus 12th term, it is going to be the 11th term. And we're out of time, everybody. What a pleasure it's been to go through some pretty tough topics with you today. Like I've said a few times, this is the first one. We've had a few technical difficulties. Thank you so much for bearing with us through that. Really hope it's been valuable for you. Please do join us next Saturday and the Saturday after that, and hopefully many, many more days to come. Not always Saturdays, of course. But yeah, thank you so much. And if you want to rewatch this, just go to examriz.com. If you want to sign up to their platform, please do that. If you want to follow me on TikTok or Instagram, I am at @thefuckingmathstutor. Yeah, I'm sure this will not be the last time we see each other. But keep working hard, and I'm sure we'll see each other again soon. Bye bye.